Hello everyone. Today's our first topic is session 1, the invested optimization. In this session, we will talk about three parts. First one is the common optimization methods. Second one is sundry unique optimization methods. Last one is some optimization cases that happens in our project. So here is a rap song about optimization, from the check solution and to especially the AP position and go on the side, confirm all the question and you confirm the AP's position if it is suitable, and then channel and the power stress if it is correct. Maybe you need to do some adjustment, and also you can test the signal interference, and those better use the dual radio and enable the flow control. Then it's calculate the batteries to confirm if the battery is enough, and then we can change the antenna and the highness of the APs. And the worst situation is change the total solution. So first one, check the solution, especially the AP position. For this part, we need to have some experience because uh, we need to analyze if the solution is reasonable, if the AP distance is reasonable, and if the AP's model is suitable according to the design. So this one require our engineer must to be and must to have lots of experience about the Wi-Fi project deployment. And also we need to understand the topology. Sometimes when we see the topology, we can say something wrong with the design, with the total solution. Then we go to the side and confirm the question, like what kind of the problem, what kind of issue that happened to this network, if this issues is consistent and intermittent. uh, in this project we usually encounter lots of the weird uh, issues, like the one station sometimes they can connect the Wi-Fi, sometimes they cannot. They were this area they can have the good Wi-Fi speed, but when they move to another area the Wi-Fi speed very slow. So for this kind of network usage we need to confirm if this issue is constant or intermittent. That's why it's very important. In lots of series, the intermittent problem is hard to solve because we need to confirm what kind of situations, what time this kind of network issue will happen. And for the network issues, we need to qualify through data. For example, if the users feel like the speed is slow, we need to test what is the speed, how many bps, how many mbps, right? And also there's like a lot the packet dropped. We need to check the packet drop ratios. And if this network issue cannot be quantified, quantified, so we need to we can use the statistical manners to help us to understand the issues. And also in the site, we solve the problem, we can take some picture and also take some videos. For example, if they say that the authentication sometimes is not work, the portal page sometimes will stuck in one place, so we can shoot a video that did a screenshot, and then if you cannot solve it you can ask for the help from the vendors, and so this uh, screenshot or the videos can help us to identify the issue also. So we need to double confirm if the AP solution is the AP position is suitable. For the uh, position. Uh, we need to confirm is this one is the same with the one we designed in the floor plan, right? And also we need to check the heightness where the APs be installed. You can see in some project, if we our partners or our clients maybe just put the AP on the floor and then lots of the AP put together. This is not a reasonable uh, deployment for our APs. So you can see that the AP in here and here. And also we need to check the obstacles around the APs. Maybe the signal is be blocked by the obstacles. And if the AP position is correct, and then we can start to do the channel planning. First, first of all, that I want our AP support the automatic channel plan, but in a large scale network, it's better we can plan the AP channel by ourselves because we deploy the AP like different floor from different floors and different rooms. We just use we stankers the AP channels. For the 2.4G, we recommend to use the 1611, and for the 5G, we have the 30 overlap channels. So yearly that most the uh, Wi-Fi interference issues is come with 2.4G frequency. And the signal stress adjustment. For this one, we need to confirm in the main area if the signal stress is stronger enough, and so I recommend is from the negative 40 dBm to negative 65 dBm. And also we need to test that other the one AP the signals from these APs 5 dB higher than the signal from other APs. If other one AP there's another AP signal very high, that's mean it will have a very high or serious interference. And also we need to be know that we should know that the higher signal stress not always mean the better Wi-Fi qualities. So in order to avoid interference, sometimes we also reduce the AP power. Further reduce the power, the signal powers is mostly happen to the 2.4G because we know that 2.4G is easy to be interference and also is good at penetrate the opticals. So usually we adjust the 2.4G signals 3 dB lower than the 5G 5G frequency. And also in some scenario, if the AP we have lots of AP deployed in the environment, we can turn off some APs 2.4G RF, so the APs will not interference to each other in the 2.4G. And also can enable the dual radio, as we say that the 2.4G has lots of issues, and the channels is overlapped to each other. So for the we can after we enable the 5G, we can in the load balancing here we can enable this prefer 5.8G frequency band. If we choose this one, that means the users will be connect to the 5G first if the terminals also support 5G. It is recommended to enable the flow control. The flow control can be in like bandwidth control based on the per stations, and also we can have the limited channel or a short channels based on the application and the user group. So this one can help us to uh, better use the bandwidth that we have in our network. And also we need to learn how to calculate the bandwidth for companies for enterprise network. We buy the bandwidth from ISP, but m- how many bandwidth we need for our enterprises? So we need to calculate the per user bandwidth, and also we need to know the concurrent users. So from this one, we can know the ISP bandwidth that we need for this enterprise or for this network. And also we can confirm the users bandwidth with this testing tool, especially there's a lot of concurrent users. We check if the speed still enough, and change the antenna. And for this one, it usually happens for the outdoor AP. Sometimes also happen in the indoor scenario. We know that directional antenna is can coverage uh, longer distance, and also its uh, signal power is centralized in one direction. So if we counter the problem with omnidirectional antenna, it's recommended to change replace with the um, directional antenna. And for the indoor projects, in some like meeting place, report hall, or some high density scenario, the indoor repeater recommend to use the directional antenna. And also for the lots of outdoor project, we need to adjust is the heightness of the APs, because if we put the AP too high or too low, it's not suitable for the coverage. So when we adjust this APs, we need to care about its tout, down tout in here. So with this one, especially for outdoor AP, if we want to cover the longer distance, this downtime can be smaller. But if you want to cover the area under the AP, near the AP, we need to have the bigger downtime. The last always the worst things happen to our project is to adjust the solution, because for this one we need to change the AP's models, right? We need to change the antennas. This I think is easy to understand, right? We choose the suitable because maybe in the beginning of the site survey, during the site survey, we chose the wrong models, and after deployment, the coverage is banned and the wireless speed is not accepted by the end users. So we can change, and also for the antenna deployment. For example, before we have one AP here and another AP here. Then during this area, maybe especially in this point, the AP here in this point, the signal to each AP is almost same. So for the users, it's hard to do the roaming. So we can use this two AP face the same direction. So when the user in here, you connect to this AP with here. So it's easy for the users to do the optimization, to do the roamings. So for example, some scenario maybe we need the zero package loss roaming. So for this kind of project, we can change to the power division solution. The AP model we use is S515. And Last, also we can change the AP models. Sometimes we change the AP with the dual baud, the EVO AP we change with the CD AP, and AP antenna optimization. We may use the direction antenna to replace the omnidirectional antenna, and we use the small angle direction antenna to replace the direction antenna, because we consider we want to coverage a longer distance. Second part, let's see the Sundry's unique optimization measures. First one is we have the fair bandwidth assignment to connected clients. We know that for some low speed terminal, they will occupy our wireless air interference in a resource. So for this kind of, sorry, to avoid this kind of this um, effect, we can enable this time fairness, the time fairness functions, and then we can enable this in RF optimization. We can enable the broadcast optimization, because we know for the wireless connections, we usually like the wireless users, lots of wireless use the same VLAN, the same layer 2 environment. If we don't do this optimization, for example, one ARP request will be broadcast to other wireless users. So if we enable this, when the ARP request will change to the unicast, and also we will prohibit the DHCP request to wireless users, because definitely we don't provide the DHCP server by the wireless. So this is the optimization here, and also in the AP. And with the same thing here, we also have the optimization for the based the per AP. That's me. If we configure this one, for example, this AP only for the normal use, it shouldn't have too much broadcast. If this uh, uh, broadcast transmit speed is uh, more than 36 Mbps, it will be not a lot. Some lots of the broadcast package will be discarded. And the low, we can reject the low rate terminals in the 2.4G or 5Gs in the max rate at the client side. We can reject the low speed terminals. This kind of low speed terminal usually like one terminal they are far away from our AP, the signal is already very bad, but that AP is still connected to this uh, terminal. So the terminals, because the negotiation speed is very low, so it will be rejected by our AP. And then we can limit the beacon frame transfer rate. For this one, recommended configuration is 9 Mbps or 11 Mbps. And also 5G first and load balance. This one we already discussed before, but we know that the principle how does this one works is use the 802.11 and the 802.11a protocol to guide the users to connect to the 5G if that terminals support the 5G. And also for the load balancing, we have these conditions. If the client's threshold is more than 10, and if this one AP connect more than 10 concurrent users, and another with the difference with another AP is bigger than the 3, and the signal stress is uh, bigger than the negative 75, and the usage is uh, channel usage is smaller than the 80%, we can do the load balance. And also we can have the enabled prevent sticking problem, because for the some users connected by AP, even they moved far a very long distance, they still can connect to our AP. So to avoid this kind of sticking problem, we can enable it here. And for the APs, error adjustment, we can enable this one so that AP can automatically adjust its power stress. For the 5G, we also can enable it on the per APs. In this per AP, uh, uh, the AP Stenti RF, here we steer the client to 5G by control the response to uh, probe frames. So these methods you can use this one at the same time because they are used different methods. First one is to 802.11k and 802.11v, but this one is you see the control the response to probe frames. For the client roamings, usually we have a counter like users, uh, same as SID, but they broadcast different VLANs. We user moved from the, for example, in the floor 1, they use the villa 1. In the floor 2, we use the villa 2. So when the user moved from the villa 1 to villa 2, it's supposed to have a new IP address. But what if the user failed to, the user terminal is failed to get a new IP address? In this situation, we can configure the client roaming. We can use these masters. That's me. Even this station didn't get proper IP address, so the data will be roaming back to its home AP. So the users Ethernet access or they want to visit the wireless net, the Ethernet, it will not be affected by this roaming. Third part is the WLAN optimization cases. Here we share the two cases. First one, it is a project in the exhibition hall. Here we provide the public Wi-Fi for the guests. We for the original solution we use the S500 Pro with the external omnidirectional antenna. This antenna is hung at the wall of the two sides. After the first implementation, the user experience is bad and their terminals, especially in the 2.4Gs, the speed is slow and when they want try to visit some website, it's hard to open. So here's the analysis about these issues. First, interference in the 2.4G Hz band is serious, and its utilization is very high. Uh, so this interference mainly from two aspects. First one, there are many private Wi-Fi in some booths because in the exhibition halls there's a lot of the booths and each booth they may use their own Wi-Fi, more like their home routers. So this caused the interference in 2.4G. And also, there's a lot of APD deployed, and they use the omnidirectional antenna. So the APs from Sundray themselves have the interference to each other. And also there's lots of the many weak signals the terminal signal is um, very weak and the negotiation speed is very low. So for this one it's caused by like the weak signals near the AP because there's lots of the boots, lots of the exhibition board. It blocks the signals, and also we use the omnidirectional antenna, and the omnidirectional omnidirectional antenna its signal overlapping with each other. So when the users walk, the users keep doing the roaming. So the connection is not stable at all. So how we do the optimization? How we do the optimization? First, we move the AP to the higher position because the signal be in the higher position, the AP signal will not be blocked by both exhibition board, right? And also we replace the omnidirectional antenna with the directional antenna because the directional antenna is power centralized in one main direction. So the signal will not overlap it between the APs. And also what we did is like we enable the low speed terminal limitation in the 2.4G, and also we turn on the 5G uh, priority function so that terminals that support the 5G will connect to the 5G frequency first. After the optimization, the user's experience is improved and the project is accepted successfully. Now let's see the second optimization case. For this one, this is a manufacturer, is a workshop. In here, we need to provide the wireless connection for the office laptop and the code scanners and some vehicle carried wireless terminals. The original solutions we use is under APs. This is very common that we use the under AP to cover the workshops manufacturer scenarios because the space is big and also the scenario may have lots of like oils, maybe sometimes it's very cold inside, so better use the outdoor APs. Um, After we finish the implementation, the user experience um, is bad, like the scanner's connection is intermittent, and when the laptop visits their Ethernet logistic system, the data speed is super slow, and the ROM is very bad. So let's analyze this issue. So the AB have the series interference because we are using the 10 under APs. Remember that our one under APs for the under AP with the omnidirectional antenna, it can cover 100 meters. We ours workshop is around 200 uh, long. So with 10 APs, definitely 10 AP signals is overlapping with each other. It have the interference to each other. And after this overlapping, and also for the users, when they do the roaming, they will keep doing the roaming because the signals, right, they overlap with each other. When the users moves, they don't know which AP is the best for itself, so you keep change the APs, so the will be disconnected all the time. So our optimization methods is we use the directional antenna to replace the omnidirectional antenna, and also we do the channel planning and enable the 2.4G low speed uh, terminal limitation, and we configure the 5G priority. So after this, the user's experience improve. Okay, so this is all for this WLAN optimization in our SCWP class. Thank you.